Good morning, everyone. I'm Dario Vezzali, and I'm a PhD student from the Marco Biagi Foundation of the University of Modena and Reggio Emilia. And today I'm going to present you a work about a decision support system to evaluate suppliers in the context of global service provider. Here you can see an agenda that basically recalls the structure of the paper we submitted. I won't go too much through the literature review, but I will try to focus more on the methodologies that we proposed and the decision support system implementation. Well, first of all, a couple of words about supplier selection, which is a well-known strategical problem in supply chain management. Many authors agree on the idea that a careful selection of suppliers might lead to long-term competitive advantages. So suppliers can be evaluated using several criteria, and we found that in the literature, quality, delivery, and cost are considered as the most popular. But they may vary depending on the context. Here, I have to say that we didn't consider cost because in the specific context of global service providers, the cost is defined as per contract between the GSP and the customers. And finally, grouping and weighting these multiple criteria is not an easy task, and that should be done carefully, and we did that in partnership with the company. So here are a couple of words about the global service provider, which are general players in the facility management industries, and they supply their customers with facility management services by subcontracting their execution to external qualified suppliers. So here in the figure, you can see the customers on the right side that sign contracts with global service provider that outsource the execution of services to external qualified suppliers. And basically in doing that, they usually evaluate more than 100 of suppliers. So in terms of dimension, this really a relevant problem. And then, given the fact that as a methodology, the multi-criteria decision analysis is particularly suitable to be applied in the context, in the supplier selection problem, a couple of words about that research field, which is well established, and that deals basically with decision problems such as ranking and sorting, where the decision process must consider multiple criteria. But in particular, we are interested in integrated approaches that combine the multi-criteria decision analysis and other methods like optimization and simulation, which are diffused as well in the literature. And finally, to complete the introduction, the research motivation of our work, which presents a real case study on the implementation of a decision support system for a multi-criteria supplier evaluation in the facility management industry. In particular, the DSS was developed to support an Italian global service provider based in Bologna, H2H Facility Solution SPA, but it's suitable to be adapted to other GSP or with small adjustments, as we will see in other contexts as well. In its activity, H2H Facility Solution supplies its customers, as we saw before, with a series of facility management services, and they can be classified as planned preventive maintenance, corrective maintenance, or extraordinary maintenance. Now, I jump directly to the problem definition of our supplier selection problem, where we have a set C of contracts that we want to assign to suppliers, and we have a set F of suppliers. And in particular, the problem is to subcontract a series of facility management contracts to the best suppliers with a double objective of maximizing the total score. And we will see how to compute this score in the following slides, and minimizing the total distance. So doing that, we introduced several parameters, which are the geographical distance, the score, the capacity of suppliers in terms of contracts, and binary parameters that consider possible preferences or potential refusals of customers toward particular suppliers. And finally, we define an alpha parameter that represents the maximum acceptable distance in terms of kilometers between the branch of suppliers and the buildings of customers. Then we define a set of binary variables that take value 1 if contract C is subcontracted to supplier F and 0 otherwise. And here you can see the mathematical formulation with the dual objective function and the constraints. In particular, we want that each contract is assigned to exactly one suppliers, but we want in doing this to satisfy to respect the capacity of each suppliers, and we want also to consider, as I said before, potential preferences or refusals of customers towards supplier, and we don't want to consider suppliers that are more distant than often. Finally, we define the domain of the variables. So we can see that this is a particular bi-objective version of the generalized assignment problem, which is particularly diffused in the operational research literature. So, as I said before, in order to compute the score of suppliers, we perform a multi-criteria evaluation, and in partnership with the company, through several rounds of interviews, we are to define the multi-level tree of criteria you can see in the right part of the slides. We have in particular 3 levels, the levels of the macro criteria, which directly contributes to the definition of the score of the supplier. And these macro criteria are further defined by micro criteria that are at the second level. And in some cases, we have also a third level of nano criteria. Of course, I don't have time to go into deep for each criterion we define. So I will focus basically on the macro criteria, which are the economic indicators that aim to evaluate the economic soundness and the dimension of the suppliers, the technical and professional capability, which aim to evaluate the organizational structure, the competencies, and the extensiveness of over the territory of the suppliers. Then we have the additional saturation capacity in terms of number of additional contracts that a supplier can accept given its organization. And finally, we define the service level performance that deeply evaluate the performance of suppliers on the basis of several historical data that we received from the company. And finally, we have the references that are specific in this context to qualify the suppliers. I have to say here that the micro and nano criteria are very context specific on the context of global service providers. So to compute the score of each suppliers, we derive this score as F as the sum of the products of weights of criteria and their evaluation, which are normalized in 0-1 interval and then scaled for better understanding in the interval 0-100. And as an example, we can see at the end of this iterative process, the score is computed as follows. We have the weights of the macro criteria, which multiply the normalized scale evaluation given the 5 macro dimension we analyzed in the previous slide. In order to compute the weights of criteria, we perform two multi-criteria decision. We applied two multi-criteria decision method, a simplified analytic hierarchy process through an online survey to which 20 respondents took part, and the revised SIMO procedure that was used basically to test and validate the results obtained from the previous method. And the answers in this case were collected through individual interviews, and 8 decision makers took part to these interviews. Well, the analytic hierarchy process is a well-known multi-criteria decision method, well-known for its flexibility and easiness of use. It was developed in the early 70s by the mathematicians Thomas Sati, and its purpose is to break down a decision into factors that usually are arranged in a hierarchical structure. Well, I have to say that in our work, in our study, we didn't use the fundamental scale proposed by Satie, but we used instead a reduced scale while performing the pairwise comparison. And the rationale behind that was that we wanted to simplify the collection of judgments, trying to minimize the inconsistencies in the answers. So for each pair of criteria, we asked the respondent to answer the following standard question, and this was repeated for each level of criteria and each pair of criteria inside each level of criteria. And we ask, what is the relative importance of criterion A compared to criterion B? So here you can see the reduced scale where we have the qualitative judgments of the top and their conversion into comparison values on the bottom. And then by applying the minor row method, we computed for each respondent the weights. And given the fact that this is a group decision process, we aggregated them using the geometric mean. So these are the results that we obtained from our simplified analytic hierarchy process. After that, we implemented a second method, a revised SIMO procedure, that is particularly suitable to assess group decision processes, and where we have several sets of criteria. In particular, the experiment of the revised SIMO procedure is a 4-step procedure, where the first 3 steps correspond to the original work, and the 4th was added in a second time to improve a few drawbacks of the original work. So here you can see the points of the experiments, and in particular, this was repeated for each level of criteria. And for each level of criteria, we gave the respondent a set of n cards with the name of each criteria written on them. And then we gave a second set of white cards having the same size. Then we asked the respondent to rank these criteria in ascending order, from the least important to the most important. And if some criteria have the same importance, they could be grouped together, of course. Then we asked the respondent to insert a white card. The principle of the insertion of white card is pretty straightforward. So the greater the difference, the more number of white cards you want to insert between 2 successive levels. And finally, we asked the respondent to estimate the relative importance of the last criterion compared to the first. So here we can see an example in order to better understand the methodology. And in particular, if we take a look to the answers of the first decision maker, the references were put as the least important criteria at the first level. Then we have the economic indicators, a white card to highlight a difference between these 2 levels. Then we have the technical and professional capabilities. And finally, as the most important criteria, the service level performance and the additional saturation capacity. So given this Z value that said that this level is 10 times more important than the first. So after that, we implemented the non-trivial algorithm proposed in this work in order to derive again the weights of criteria for each respondents, and aggregating them again using the geometric mean. And as you can see, we found that the 2 results were really consistent between each other. So given the validation of the results from the revised SIMO procedure, we decided to use the weights found by applying the simplified analytic hierarchy process. So after the weights computation, we implemented the decision support system, which is composed mainly by 2 main modules. Here, I have to say that I have some backup slides of the front end, which was implemented using HTML plus CSS and JavaScript language. But in this presentation, I will focus more on the back end, which is implemented using C++ language. So I was saying that we have 2 main modules, a database that stores data regarding contracts and suppliers from a huge time horizon of 7 years. And these data were provided by the company. And then we have a second module that is responsible for evaluating the score of each suppliers and normalizing and the normalization and scaling process of each criterion. Well, in order to give to the decision makers a reduced list of candidates as an output, a reduced list candidates to which a contract could be assigned, we introduced this weighted function that we called assignment score, that basically gives a score to each supplier based on its score from the multi-criteria decision analysis, and a score considering the distance between the branch of supplier and the building of the customer. These two-dimensional scores are multiplied by this delta multiplier, which can be selected and customized by the decision maker, and that basically varies between 0.1 and 0.9. So after having introduced the assignment score, we implemented the third module that has inside a greedy heuristic algorithm that for all the contracts that we have stored in the database, try to assign each contract to the best supplier, so the supplier having the highest assignment score. Here you can see the pseudocode. I don't have time to go into deep into all the lines of the pseudocode, but note that we apply this pseudocode all the day in the simulation horizon, but of course this simulation horizon can vary given the available data or given the desiderata from the company. And finally, we perform some computational tests trying to vary the multiplier delta between 0.1 and 0.9 and 0.9, yes. The results were evaluated based on the assignment score. Here in the graph on the right part of the slides, you can see the different scenarios that were evaluated based on an average score of supplier and an average distance that in this case is expressed in kilometers. We have also two dominated solution. And if we go in detail through the computational results, we can see that we gave a slight preference to the solution where the relative importance of the score of suppliers is 0.6 and 0.4 is the relative importance of the distance. But we have other good solution that gave the same assignment score. So going through the conclusion, we think that our contribution are the following. So we used a couple of multi-criteria decision methods, the simplified analytic hierarchy process and the revised sigma procedure to compute the weights of a complex and multi-level tree of criteria. And we found that the obtained results were consistent between each other. Then we defined the specific supplier evaluation and selection problem of our case study by using a multi-objective integer programming model that I have to say was not implemented in the mathematical solver, but it was just used to describe the problem and consider a set of constraints, and it was preceded the implementation of the greedy heuristic algorithm that on the other hand takes into consideration some dynamical aspects of the problem that weren't addressed by the model. Then we built our case study in a broad database of 158 suppliers, which in terms of dimension of the problem is relevant because we didn't find such a dimension in the literature relating to other case studies. Then we performed extensive simulation, and the proposed methodologies were implemented and integrated in a DSS prototype. which was delivered to the company with a user-friendly interface. So really concluding, we think that the proposed approach is extremely flexible, highly repeatable, and that can be reiterated from the company at regular intervals if needed. It could be adapted with small adjustments, as I said before, to other real-world supplier evaluation problems in different contexts as well. And as a future work, we intend to perform deeper computational evaluation of our methods to further investigate the selection of macro, micro, and nano criteria in order to express few dimensions more exhaustively. And finally, we are willing to implement analogous decision support systems for other real-world applications. So saying that, I really thank you for your attention, and if you have any question, I'll really be pleased to answer.